Hello everyone, and thank you for tuning into our webinar, Pyrolysis, Expanding the Characterization Options of GC and GCMS. I'm Nicole, the GCMS Product Manager at Shimadzu Scientific Instruments, and I'm joined today by Rosine from Frontier Laboratories, which makes pyrolysis units. Today we will be speaking to you about application market spaces that pyrolysis is used in. Before we get started, I wanted to let you know a little bit about the platform. Feel free to click around and expand or move the items on the screen as needed. At the bottom of the screen is the toolbar with everything you need in the webinar. If you have any issues during the webinar, be sure to click the question mark to get assistance from technical support. If you have any questions about the content in the webinar, feel free to ask us using the Q&A button. I'm not sure that we'll have time for questions today, but we would love to hear from you and get back to you after the webinar is finished. Also, because this webinar is the first in our series on PYGC-GCMS, we may use your question in a future webinar, so definitely remember to sign up for the additional webinars in the series. Finally, we have a few items for you to download in our resources section, so don't forget to check that out as well. I just wanted to take a minute before starting the webinar to thank you all for attending today. I would like to mention that both Shimadzu and Frontier are celebrating some pretty big milestones in 2020 and 2021. First off, Shimadzu Corporation is not only celebrating its 145th year as a company, but this is also our 50th year of mass spectrometry. The magnetic sector GCMS that started it all is pictured on the top left. Also, our friends at Frontier Laboratories are celebrating an anniversary. This happens to be their 30th anniversary as a pyrolysis manufacturer. A big thank you to all of our customers and new friends for tuning in. Interaction time. See, and you thought you weren't going to get to be part of this conversation. We have a quick question before getting started. How many of you in the audience are currently using PyGC or PyGCMS in your day-to-day work? Go ahead and make a selection. I promise there is no right or wrong answer here. The goal of our webinar today is going to be to educate on the types of places a pyrolyzer can be used. While pyrolysis is a very special sample introduction device, which might make it seem like it only has a few uses, I hope by the end of this you will see its versatility. With that, I'm going to turn this over to Rosine to tell you all about the uses of pyrolysis. Take it away, Rosine.
Thank you very much, Nicole, for the introduction. So here is our agenda for today. We will first discuss why pyrolysis is important and what are the different types of pyrolyzers in the market. Then we go over the micro-furnace pyrolyzer modes of operation and where you can use this technique. After that, we have some short application notes as examples to show the capability of micro-furnace pyrolyzer. So by the end of this presentation, you will have a good understanding of why you want to use pyrolysis GCMS and how this technique adds value to your lab. In a few seconds, I'm going to show you guys a short clip about why pyrolysis. So in summary, the multifunctional micro-furnace pyrolyzer really expands the application of your GCMS instrumentation. This technique enables the analysis of organic material from gases to solids, even including insoluble solids as is, without any solvent extraction, or sample filtration. So there are three different technologies in the market to perform flash pyrolysis. As you could see on the left-hand side, there is the filament pyrolyzer, which uses a cold wire, Curie-point, which employs a ferromagnetic foil, and then vertical microfurnace, which uses a low thermal mass ceramic furnace. The microfurnace pyrolyzer directly connects to your GC injection port, so there won't be any transfer line. With the microfurnace technology, sample introduction is also instantaneous. The sample is placed in an inert sample cup and is held at near ambient temperature in helium while it is not subjected to any heat before the analysis. The microfurnace is then preheated to the desired temperature. For example, you set your furnace at 600 C for flash pyrolysis, and that temperature is precisely measured with a thermocouple sensor. The sample cup then drops into the quartz pyrolysis tube, where the sample is rapidly and reproducibly pyrolyzed. And then all the pyrolyzates are directly swept onto your GC column for separation and then the detection by MS in this case. So this technology directly deposits all pyrolyzates on column in a single step for a continuous mode analysis. Now, this single step process of the microfurnace allows low and high molecular weight, as well as polar compounds to be detected and analyzed. As I mentioned, the absence of any valves or transfer line is also critical for the ability of microfurnace to detect heavy and polar pyrolyzates as well as any additives and light compounds. Microfurnace also allows a full range evolved gas analysis, EGA, to obtain a thermal profile of an unknown sample for light and volatile compounds, additives, any oligomers, polar, heavy, and polymer compounds. These EGA, evolved gas analysis experiments, can be performed from 4 C to more than 1000 C. And they correlate results with the well-established TGA, thermal gravimetric analysis techniques, throughout the entire temperature range of the experiment. And lastly, but one of the most important points, the microfurnace technology guarantees reproducibility and accuracy of the temperature within plus or minus 0.1 degrees Celsius. All surfaces are quartz and temperature stable deactivated. Again, there is no transfer line, no cold spot, and no cross-contamination. On the other hand, filament and Curie-point pyrolyzers can suffer from poor temperature accuracy and poor reproducibility because of their non-uniform heating. In both systems, to avoid condensation of the pyrolysate, the sample must be inserted into a heated manifold prior to the pyrolysis. So this preheating step can cause degradation or thermal setting of the samples prior to the analysis. With filament pyrolyzer, sample placement and heat transfer variation also affect the temperature of the sample, depending on where the sample sits in relation to platinum wire coils and on sample contact. The filament temperature is then estimated from the electrical properties of the wire, but the temperature of the sample is not actually measured as it changes over the time. Some of the filament pyrolyzer uses a two-step process in which some of the pyrolyzates are first collected on a trap. A switching valve is then used to send the pyrolyzates from that trap through a long line into the GCMS. Now, during this two-step process, polar and heavy compounds may cause cross-contamination or be irreversibly stuck in the trap or the long transfer line and are not transferred for analysis because of the potential of cold spots in the system. So, in summary, what sets microfurnace technology apart from the other pyrolyzers in the market? With a direct connection to the GC injection port, no transfer line, no switching valve, and performing a continuous mode pyrolysis, with microfurnace pyrolyzer, all the pyrolyzates are continuously and directly transferred in a single-step process into GC as they are generated. So heavy and polar compounds are directly placed on column, and light compounds are not lost. Also, as I mentioned, you place your sample in an inert sample cup that is held at ambient temperature and is not exposed to any heat prior to the analysis. Therefore, there is no chance of evaporation, degradation, or thermal setting before the analysis. Also, the sample is purged of oxygen before heated, so there are no oxidation reactions as well. Critical for evaluation of unknown sample, the microfurnace performs a full range evolved gas analysis experiments from 40 C to 1050 C over 1000 C and correlate results to the well-established TGA thermal gravimetric analysis techniques throughout the entire temperature range of the experiment. And then microfurnace pyrolyzer also controls the actual sample temperature to within a plus or minus 0.1 degrees Celsius set point of the pyrolysis furnace. But other pyrolysis devices only control the temperature of the heating element, not the actual sample temperature. So as we learned from the first series of the webinar, the microfurnace is a multifunctional pyrolyzer, which means that this technology allows you to perform multiple analytical techniques in addition to flash pyrolysis, both isothermal and temperature program. For example, you can perform evolved gas analysis, multi-step thermal desorption, or hard cutting in addition to flash pyrolysis. Now, you're probably asking yourself, how do I use the microfurnace and all of these different modes of operation for material characterization? We have developed a method map that provides you with 2 simple steps for identifying the organic composition of any unknown samples, including solid samples. EGA, Evolved Gas Analysis, is the first step, which provides a clear picture about the thermal profile of your sample. Then the second step is to use your obtained EGA thermogram to define the thermal zones of interest. So EGA really guides you what to do next. It will show if a thermal desorption, hard cutting, or flash pyrolysis is needed, or if a combination of the techniques is required. Here is the analytical flow diagram for characterization of unknown samples. As I mentioned, EGA, Evolved Gas Analysis, is the first step and provides information about the thermal profile and complexity of your sample. Now, to perform EGA, a short and deactivated tube is used and a plot of detector response versus furnace temperature is obtained. Then use your EGA thermogram to identify the thermal zones of interest. Single shot or flash pyrolysis is a fundamental technique for polymer analysis. In this mode, the furnace is programmed at a high isothermal temperature. For example, you program your furnace at, say, 600 C to break down the heavy and polymeric compounds into smaller fragmentation called pyrolyzers. You obtain a pyrogram that indicates all the features of the samples, all the additives, and all the fragmentation of your polymer. Now, if you decide to do double shot analysis, that's the combined analysis of thermal desorption and pyrolysis with one-time sampling. You obtain the results of thermal desorption analysis of volatile compounds or additives from your polymeric fraction of the sample. In the hard cutting mode of operation, the EGA thermogram can be sliced into multiple temperature zones or thermal zones, and you obtain separate GCMS chromatogram for each of those zones for detailed material characterization. So start with your EGA, that is the thermal analysis, and then follow your EGA to see if you need to do single shot, double shot, hard cut, or maybe a combination of all of them, but these are all the separation analysis. Now, let's talk about the application areas of pyrolysis GCMS. In other words, where can you use this technique? Today, analytical pyrolysis really encompasses much more than simple pyrolysis of polymeric compounds. Virtually any sample can be characterized using an array of techniques that are designed into the modern-day multifunctional microfurnace pyrolyzer. The versatility of this technique allows customized chemical analysis of everyday life samples in pretty much any industry, as you could see from this table. Not only you can use this technique in a variety of application areas such as deformulation, contamination, comparison, quality control, and unknown analysis, This technique is also used for material characterization of any sample in various industries. For example, additives, plasticizers, surfactants, volatiles, films, impurities can all be analyzed from a mixture of polymeric sample in many different industries, such as paint and coating, petroleum, plastics, elastomers, microplastic, and consumer products, just to name a few. With pyrolysis GCMS, sample consistency, it doesn't really matter. You can analyze solids as is, liquids, gooey or viscous samples, while any sample preparation or pretreatment such as solvent extraction can be eliminated. Now, depending on your sample type, you use a proper sampling tool to place a few micrograms of your sample in an inert sample cup and start the analysis. The characterization of products, both chemically and physically, is very important. Chemical composition of items is typically achieved by analyzing the product in its final form. Some of the areas of interest using pyrolysis GCMS are automotive interiors, tires, and plastic, compounds, and manufacturers. As I mentioned earlier, virtually any sample can be analyzed using this technique, including gas samples. So we have two different types of solid phase extraction elements. We call them SPEE, polar and nonpolar. They're used for analyzing trace amounts of organics in air. An example of this type of application is analyzing the smell in a new car using these SPEE. Paints, primers, and pigments are other application areas of micro-furnace pyrolysis GCMS. In addition to material characterization, you can also perform failure analysis for quality control or compliance with required regulations. Some examples of the application areas of interest using PyGCMS are identifying additives in paint, or paint degradation analysis and stability using micro-UV irradiator pyrolysis GCMS, which is a rapid photo and thermal oxidative degradation analysis of paints and coating samples. Food and consumer products span many industrial areas from food processing to packaging to cosmetics. Chemical composition is important, but also off-gassing from the materials plays a role in what can be used to generate things like containers. Some examples of application areas of interest in food and consumable products using the microfurnace are food packaging safety, fatty acid analysis in food and cosmetics, medical devices, and electronics are also application areas that pyrolysis GCMS is used for material composition and the chemical composition characterization, as well as off-gassing analysis. For example, IEC, International Electrotechnical Commission 62321-8, shows the identification of certain substances such as phthalates in electrotechnical products using the microfurnace. Children toys are one of the main areas of concern in consumer products. Chemical composition analysis of toys are critical as to know what could be coming off the product held by children. ASTM D7823-18 shows the quantification of 6 regulated phthalates in a PVC matrix using the microfurnace thermal desorption modes of operation. Other examples of application areas of the interest are analyzing bisphenol A in polycarbonates, BHD and ergonox 1010 in polymers, and also identifying brominated flame retardants as well as anti-degradants in elastomers. Microfurnace pyrolyzer also has applications in energy, petroleum, and biomass. Our customers are using this technique in various ways, such as hydrocarbons profiles in shale oils and rocks, as well as high-temperature fuel additive analysis. Also, this technique is being used as an alternative to rock eval instrumentation, while it provides much more detailed info about the rock composition for sulfur-containing compounds. One of the current hot topics is analyzing microplastics in the environment and its effect on oceans, sea life, birds, and humans. Recent studies of micro-furnace pyrolysis GCMS on analyzing microplastics is another application area that has proven the capability of this technique. Microplastic materials often contain a variety of polymers and additives, and in most cases they correlate. So identification using a spectroscopy technique such as IR is challenging. However, the correlation of compounds and contamination in a microplastics mixture sample does not affect micro-furnace pyrolysis GCMS ability in simultaneous identification and specification of polymers and additives. Sample preparation is also easy and straightforward. Micrograms of the sample, including solid as is, are placed into an inert pyrolysis cup, and the analysis can be performed. The in-progress development of an automated library search called AppSearch for data processing has also significantly shortened the time needed for the analysis. Forensic laboratories are another group of our users, our customers. They perform material characterization on their samples using the microfurnace to investigate different cases. A few examples of application areas for pyrolysis GCMS are being able to differentiate types of fibers and inks, detect trace amount of drug stain on cloth, analyze paint and coating on different surfaces, and also perform arson product analysis. Now that we have a good understanding of where the microfurnace pyrolyzer can be used, let's go over some application note examples to show how this technique expands your capability in day-to-day sample analysis. Here is an example of using the double shot mode of operation using the microfurnace, which is a thermal extraction of additives and volatiles from the polymeric and heavier content. To perform chemical composition analysis on a compounded rubber, evolved gas analysis was first performed, as I mentioned as the first step, to obtain a clear picture of the thermal profile of the sample. Now, as you can see here, the EGA thermogram that was done from 100 to 700 C at a rate of 20 degrees per minute shows a small hump at the region between 100 to 300 C and an intense peak at the higher temperature profile. Now, using the double shot mode, you can first perform thermal desorption on your sample by programming your microfurnace from 100 to 300 in this case, based on your EGA thermogram, and obtain a thermal desorption chromatogram that corresponds to the additives in a sample. Then, on the same sample, you can perform flash pyrolysis to break down the heavier and polymeric fraction of your sample. In this example, a vulcanized agent and antioxidant waxes are detected in the TD, thermal desorption zone, and the natural rubber in the pyrogram from the flash pyrolysis. Now, let's take a look at an example for failure analysis or comparison analysis of a good versus bad sample. In this application note, we want to compare two polypropylene samples, good product versus the bad one, to identify the cause of the failure, which in this case is defined as odors or smell in a bad product. Again, EGA was first performed on both samples, and an optimal thermal desorption temperature zone of 50 to 100 C was identified from the EGA thermograms. By analyzing the peaks from the thermal desorption chromatograms, we can conclude that the effective sample contains a number of volatiles. As you could see, there are some low boiling alcohols, which are not present in a good sample. Therefore, these volatiles can be the cause of the odor and smell in the defective sample. Lastly, let's see how we can perform deformulation analysis using the microfurnace system. In this example shown here, an adhesive tape is analyzed first using EGA mode of operation to identify the thermal profile and temperature zones. To perform EGA, we program the microfurnace from 40 to 600 C in this case and obtain the EGA thermogram shown as Figure 1 that has three peaks or zones A, B, and C, as you can see from Figure 1. Now, to chemically characterize each zone from the EGA, we use the hard cutting mode of operation, which is the thermal slicing of the EGA by programming the microfurnace into 3 temperature zones and obtaining separate GCMS chromatograms to identify the component in each zone. So the analysis of each thermal zone yields a chromatogram containing only those compounds evolving from the sample of the selected temperature range. Hard cutting mode of operation is one of the most powerful techniques for deformulation or reverse engineering analysis because you can obtain detailed information about the chemical composition of your sample as compounds released from any temperature zone in an EGA thermogram are selectively introduced into a separation column. So in summary, why do you want to use Pyrolysis-GCMS technique? Pyrolysis-GCMS enhances efficiency in sample analysis and reduces solvent costs in your lab by eliminating any solvent extraction, filtration, and concentration. In fact, as I mentioned, any sample type, including solids, the insoluble solids, can be chemically analyzed as is without any need for sample pretreatment or sample preparation. Micro-furnace pyrolysis-GCMS also expands the application areas of your GCMS. It can analyze the insoluble materials that cannot be analyzed using your LC, LCMS, GC, or GCMS. So Pyrolysis-GCMS broadens the range of organic material characterization from the gases all the way to the solids that are even insoluble in any type of solvent. Finally, Pyrolysis-GCMS enables you to perform multiple analytical techniques with one instrumentation. As I mentioned, you can perform evolved gas analysis, which is a rapid screening technique for evolved gases, and that's a thermal separation, that's a thermal analysis. Or you could perform thermal desorption for thermal extraction of additives and volatiles from a mixture of your polymeric sample. Or you can perform true flash pyrolysis with no transfer line and precise sample temperature. Or hard cutting to thermally slice the EGA for detailed chemical composition analysis. And also a double shot, that is a thermal desorption followed by flash pyrolysis on your sample. So that's all I had for today. I hope you guys enjoyed my talk, and now I would like to turn the mic back to Nicole for finishing this event. Thank you.
Thanks, Regine. Before we close this out, I'd like to ask one more question. You didn't think you'd get away with not answering another question, right? After all that you've heard today, would this be a technique you would consider adding to your suite of testing techniques? Personally, after working with PyGCMS, it always amazes me the types of samples that can be run on the system. While it doesn't work for everything, it is definitely a nice alternative or tool in the box for testing a wide variety of samples. I'm going to give everyone a few more seconds here to make a selection before we end our presentation. Wow, this has been a lot of great information about using the Pyrolyzer with GC and GCMS. The applications using the sample introduction device adds to the endless possibilities in the areas of characterization, difficult matrices, and so much more. As was mentioned at the beginning of the webinar, I don't think we're going to have time for questions today, but those of you who have asked, we will be contacting you directly after the webinar to get those questions answered for you. Also, if you're interested in pyrolysis, we will be holding another webinar in about a month where we will go over a few very specific applications based on the market spaces we spoke about today. Please be sure to check out our next in this pyrolysis series. A big thank you again to Regine for joining us, and we look forward to seeing you all in our next webinar on PyGCMS applications. Thanks, and have a great rest of your day.